Okay class, let's look at this mechanics question here. Let's label what we can to start off with. We know that's 15G. Now there's a normal reaction here. We have the coefficient of friction, which is 0.2. So remember, the F max, the frictional max, equals mu r. We have mu, so that's 0.2 r. That should get us some method marks already. Now, because it's going along a plane, it can resolve horizontally and vertically. And if you look at the direction of the force, we can draw the arrows like so. So we'll know that this is the opposite, so this must equal P sine 50, and this is P cos 50. That's step one to answering this. Now the box is on the point of sliding along the plane. There is a point of sliding, the force this way is going to equal this F max, the frictional max from before. So that force is going to equal, resolving horizontally, P cos 50. Now let's resolve vertically. What do we have? P sine 50. So P sine 50. You can see the R here. Plus R is going to equal 15G. Now to find P, we need to substitute some values in. So let's find R, and let's isolate R and make R the subject. So R equals 15G minus P sine 50. So the F max is going to equal 0.2 times 15G minus P sine 50. Now we know this F max is going to equal P cos 50 because the point of sliding along the plane. So we can say P cos 50 now equals the above, which is 0.2 15G minus P sine 50. That's just wonderful. Now if we want to isolate P, we need to expand and make P the subject. So expand the bracket, P cos 50 equals 0.2 times 15, so that's a fifth of 15, so that's 3G minus 0.2 P sine 50. Let's bring this over to the other side, so we get P cos 50 plus 0.2 P sine 50 equals 3G. Can you see we can take P outside the bracket? So we're going to get P cos 50, shouldn't close bracket there, plus 0.2 sine 50 equals 3G. Because I've done that, I'm just going to do this. So P is going to equal 3G all over this cos 50 plus 0.2 sine 50, and that will equal P equals 37 to two significant figures. Try it on your calculator. To three significant figures, it was of course P equals 36.9, and I'd probably prefer to write to three significant figures. Now let's start off with this question. Pause the video and have a look. But we know tan alpha is 3/4. So if we have a triangle, that's 3, that's 4, because that's the opposite. This is the adjacent, and we know Pythagoras, that must be a 5. So to help us out, sine alpha is opposite over hypotenuse, that equals 3/5, and cos alpha is adjacent over hypotenuse, that's 4/5, equals 0.8, and that's 0.6. Now this is going to help us start the question. Now we have 4n acting this way. It's held at rest by the action of a force of magnitude 4n acting up the plane in a direction parallel to a line of greater slope of the plane shown in figure 2. The particles are on the point of slipping up the plane. So you've got a force acting up here. We're going to have a force this way, the normal reaction, remember mg, so that's 0.5 g, and friction is going to be acting against the plane. We do not know the coefficient of friction, but we know F max is going to equal the total force because it's held at rest. So F max equals mu r. So what can we find? Can we find r? So let's resolve this way. So that's alpha. That must be alpha. So depends which way you want to resolve, but we can say R equals what's acting this way. So let's label this. This is opposite, so this must be 0.5 g sine theta, which in turn is going to equal 0.3 g, because sine theta is 0.6. Acting down here, that's going to be 0.5 g cos theta, which is going to be 0.4 g, because cos theta is 4/5. So just resolving this way, we get R equals 0.4 g. Now resolving parallel to the plane, we get 4 must equal the friction F max plus 0.5 g sine theta, which we know is 4 equals F max add 0.3 g. They must equal because the particle is on the point of slipping up the plane. So we substitute what this is, so we get 4 equals mu, and we have r from before, mu times 0.4 g plus 0.3 g. Now we resolve by doing 4 minus 0.3 g equals 0.4 g mu here, and you'll get mu to be approximately 0.27. So that's part A, quite easily done. Now let's look at part B. The force of magnitude 4n is removed, so this is taken away. So if it's about to move up the slope but it's removed, it's going to, through gravity, move down. So we do a new force diagram here, and we've got acceleration, because let's find the acceleration of P down the plane. So what information do we have from before? We're going to have to use this. Now we know F equals ma. So we have F equals, because we have the mass, 0.58. That's something we're going to have to use. So this acceleration, if we resolve parallel to the plane, that's got to equal this force, and we can call that a force going this way, because we need acceleration, and this is which F max. So we know 0.5a is going to equal everything going this way. So how are we going to work that out? Well, the angles are the same from before. What do we have here? That's 0.3 g from above. Remember here. So 0.5a is going to equal 0.3 g because that's all we have acting this way, minus the F max, the force going this way. Now what is F max? F max equals mu r. So we need to find out what r is. So let's look at r. The normal reaction, r, has to equal what's going this way. It is from above here, the 0.5 cos theta, so that is 0.4 g. Because cos theta is 4/5. So r is going to equal 0.4 g. So we're going to substitute this all into here, so it's clear. Minus mu r, so that's 0.5a equals 0.3 g minus 0.27 times 0.4 g. So the acceleration, once you divide by 0.5, divide by 0.5, do this carefully on the calculator, is going to be 3.76 meters per second, or 3.8 depending on how you want to round it. Okay, so let's look at this exam question now. We've got a parcel mass 5 kg, so let's label this diagram now, or just draw a separate one. So that's 5g. We know tan alpha is 3/4, so we have this type of triangle. That's a 3, 4, 5 triangle. So we get cos alpha in this instance is adjacent over hypotenuse, which is 4/5 equals 0.8. We're going to use that later to make our sums easier. And then sine alpha is opposite over hypotenuse, so that's 3 over 5 equals 0.6. Right, so let's read this question. It's held in equilibrium by the action of a horizontal force of magnitude 20 newtons, so it's held in equilibrium. The force acts in a vertical plane through a line of greatest slope of the plane. The parcel is on the point of sliding down the plane. Find the coefficient of friction between the parcel and the plane. So that's where we can use F max equals mu r. So we're going to have friction because it's about to slide down the plane, so F max is acting this way. We need a normal reaction acting perpendicular to the plane, and we have 20 newtons going that way. So if we resolve this way perpendicular to the plane, let's use this 5g here. Now that's going to be alpha so this is the opposite, so that is sine, so that's going to be 5g sine alpha, which we know is 0.6. Sine alpha is 0.6, so that's going to become 3g. This is 5g cos alpha is 0.8, so that's going to be 4g. So let's just resolve this way. So we've got the right angle here. Now we can see this force of 20 newtons up the plane is going to give us, that's alpha here because of the z angle, alternate angle. Hope you can see that. You can see this is going to be 20 times cos alpha, which we know is cos alpha is 0.8, so that's going to equal 16. This way is going to be 20 sine alpha, which is 0.6 times 20, which is 12. So if we look at all the forces going this way now, we can see we get R minus this 5g cos A minus 4g minus 20 sine alpha, which we know is 4g minus 12. Now it's on the point of sliding, so it's going to equal 0. So we can say R equals 4g plus 12. So R equals 51.2 newtons. Now let's go this way. We can see we've got F max is actually going to equal, we see F max is going to equal everything going this way. It's going to be 5g sine alpha minus 20 cos alpha, or you could just say F max, you can see it's going in the same direction, plus 20 cos alpha equals 5g sine alpha. We have figures for these, so F max plus 16 equals 3g. Now remember, F equals mu r. Let's go to here, so F max equals 3g minus 16, which equals 13.4 newtons. So let's substitute those values in. We've got 13.4 equals mu times 51.2. So mu equals 0.262. Right, I hope that question makes sense to you.